Assalamualaikum and hello. In this video, we are going to focus about reaction of alkenes one by one. In the previous video, I talked about the type of reaction for alkenes, which is electrophilic addition. Now we are going to focus these all reactions one by one. Let's go to the first one, halogen in inert solvent. The name of this reaction is halogenation, where you are going to use halogen adds to whether chlorine molecule or bromine molecule. The next one, you need to use inert solvent, where you can choose dichloromethane CH2Cl2 or tetrachloromethane CCl4 or benzene. And when writing down the chemical equation, I use the general one, propene. So propene reacts with H2. So this is where you are going to replace in your specific equation whether Cl2 or Br2. With inert solvent, I'm going to use dichloromethane. So what will happen, I'm going to break the double bond here. This bond will break and I'm going to add up two Cl atoms. And in this case adalah awak punya halogen, two halogen atoms. So my product will be like this one, CH3 bonded to C, bonded to C, and I got this one as my original structure. And now I'm going to add up two single bonds that attach to two halogen atoms. So this is going to be your major product. And this product is what we call as vicinal dihalides. It means that two halogen dihalides at the position side by side, vicinal. So settle for the first reaction. Now let's continue with second reaction, which is hydrogen in the presence of catalyst. The name of this reaction is hydrogenation, where we are going to start from alkene reacts with hydrogen H2. We will use catalyst either platinum or nickel or palladium. And when you do this reaction, you need condition which is heat. So there will be triangle symbol under the arrow. And what will happen, this reaction as usual, it will break the double bond here. And then I'm going to copy back the product as original as this structure without double bond. I will get CH3 bonded to C. You got H bonded single bond, H and H. And at this product, we are going to add up two single bonds where both of these are going to attach with two hydrogen atoms. So what can you form here? You got alkene as your product. Settle for hydrogenation of alkene. Now we are going to continue with the acid catalyst hydration, and it is a reverse reaction of dehydration of alcohol, where for dehydration of alcohol, we will use alcohol as reactant. But right now, for this case, we are going to use alkene as reactant, and it will undergo hydration process by adding water, H2O. That's why the name of reaction is hydration. So you got H2O plus with the alkenes that you have, and you need acid. And acid that we will use usually H2SO4. Please use this formula in your equation. And next, what will happen, you will add up H and OH. So I'm going to copy back my structure as it is without double bond. So I got H3C bonded to C, bonded to C, and I got hydrogen at each bonds. And right now, we are going to add up two single bonds. And these single bonds, one of them is OH and another one is H. This is where we are going to apply Markovnikov's rule, where I'm going to add hydrogen at carbon-carbon double bond, which is this case. As you see here, this is the first carbon, and this is the second, this is the third. So I'm going to add up OH group add more substituted carbon. More substituted carbon means that carbon with more alkyl groups. In this case is carbon number 2 because we got CH3 at this third carbon as our alkyl group. So right now this one will be OH and carbon number 1 will attach with hydrogen. So I'm going to get my final product like this one. Make sure this one bonded carbon to oxygen, not in the middle, not at hydrogen. It must be connected to oxygen. So you can see from here, your product is alcohol. This is because you hydrate this alkene by adding H2O. Now we are going to continue for the next reaction, halogen in water. So previously we got halogen in inert solvent. Right now we got halogen in water. The name of this reaction is Halogenation, where we got our alkene reacts with our halogen. I'm going to use the general one, X2, and you must put the extra reagents here, which is H2O because hydration. Halo means for halogen, hydration means you hydrate them, so you need water. So what will happen, you are going to break this double bond because you use addition reaction. So I'm going to copy back my product without double bond, and from here you got two single bonds, and in this case the atom and groups that will be added is X and OH. So we got X plus and OH minus. So we are going to follow Markovnikov's rule, where the more positive reagent, in this case is our halogen X plus, will be added to carbon that has more hydrogen atoms. So we can see that this carbon got two hydrogen. So X will attach here. So you will get X here, and for this carbon you will attach to OH. So I will have OH here. Another way that you can explain that, OH will be added at more substituted carbon because you got alkyl group at this carbon. You can use whichever reason that you want. So please be careful, make sure you add OH and X at the correct position. So this product is what we call as halohydrin. Next one, we go to the fifth reaction, where this reaction is very special because we will have mechanism for this one. But in this case, I'm not going to explain more about that. We're going to focus a lot about mechanism in the next video. But for now, I'm going to continue with the reaction, where this reaction is what we call as hydrogen halides. And the name of the reaction is HydroHalogenation. Hydro means hydrogen, and halogenation means you use halogen in your reaction. So when I said about hydrogen halides, of course we are going to use HX, and X can be Cl or Br. And in this case, what will happen, you will break this double bond by adding two single bonds. So I'm going to copy again the same method as before without double bond. So you can see that this is the product that you have with two extra single bond. And in this case, you are going to add X at more substituted carbon and H at less substituted carbon. So the more substituted carbon is this one, and less substituted carbon is this one. So this carbon will be attached to hydrogen. So this hydrogen is coming from HX, and this one will attach to X, your halogen, coming from HX as well. So this is where you also follow Markovnikov's rule. So it is very important for you to understand Markovnikov's rule, and this product is what we call as haloalkene because you got alkene with halogen inside the structure. That's why the name will be haloalkene. Let's go to the last reaction, where I got hydrogen bromide in the presence of peroxide. And this reaction is the same as the fifth reaction. We call it as hydrohalogenation. When I talk about peroxide, I'm going to introduce to you a few peroxide that we can use in this reaction. The first one is hydrogen peroxide, where the chemical formula is H2O2. You can also write it down in the form of HOOH, or you can write it down also as H bonded to O bonded to O bonded to H. So this one also acceptable. So right now we got another one more example for peroxide, which is ROOR, and then R can be any alkyl groups that you want to use. Usually we can use it as methyl peroxide. So methyl peroxide, the chemical formula CH3 bonded to O and bonded to CH3. And you can write it down in a simpler form, CH3OOCH3. So usually these two peroxides can be used in hydrohalogenation for this reaction. So let's get back to this reaction where you got your alkene. You are going to react the alkene with hydrogen halide, either HCl or HBr, and you must put H2O2 or your peroxide. So in this case, you are going to break this double bond as usual, breaking this double bond, but we will apply anti-Markovnikov's rule in this reaction. So it means that we are going to add our positive reagent at more substituted carbon, not the less substituted carbon. So it's going to be at the position different from before, the opposite to Markovnikov's rule. So I'm going to copy back my structure for the product without double bond. So this is going to be my structure, H3, C, bonded to C, you got hydrogen. Bonded to C, you got another hydrogen and another one more. And you got two single bonds. So right now, we are going to use anti-Markovnikov's rule, where I'm going to add up my positive reagent is H plus from here. H plus will be added to more substituted carbon. So the more substituted carbon, if I give the numbering, this is going to be the numbering based on here, the structure of the reactant. H plus will be added to carbon number 2, the more substituted carbon, because we will reverse the Markovnikov's rule. So I'm going to put H here, and X will be attached to first carbon. So it's quite different from the previous reaction. The product will be the same, also haloalkane, but the name will be different. So I hope you are clear with the reaction of alkenes, where you've learned 6 of them: halogen in inert solvent, hydrogen in the presence of catalyst, acid catalyst hydration, halogen in water, hydrogen halides, and the last one, hydrogen bromide in the presence of peroxide. If it asks you to use bromide, you can use HBr. If it asks you to use hydrogen chloride, you can use HCl. So whichever depends on the question. So I hope you are clear with how to use Markovnikov's rule in the reaction of alkene. And please remember, alkene can only undergo electrophilic addition reaction, which forming only one product. So there is no side product in the reaction of alkene, as you see from all these 6 reactions. So that's all for this video. I hope you've learned a lot and you can memorize all the tips that I taught you in this one. That's all from me. I'll see you in the next video. Thanks for watching. Bye.